This is the next question. It says a smart irrigation system uses 4 conditions to water the plants: soil moisture A, temperature B, sunlight sensor C, water tank level D. Each value, each input has states that represent the different physical conditions. The irrigation pump turns on F is equals to 1 if the soil is dry, the water tank is full, and the temperature is high or the sunlight is bright. Okay, so they're saying the soil is dry, which means A is equals to 0, and even though there is a comma here, that comma just represents and, okay? A is equals to 0 and water tank is full, which is D is equals to 1, okay? And the temperature is high or sunlight is bright. Okay, so this is the OR condition. So it will be either B is equals to 1 or we have C equals to 1. So this is what we have. Now we have to draw the truth table and then find the answer. So the first step is we are going to find the truth table. We are going to derive the truth table. They said A is equals to 0 and D is equals to 1 and B is equals to 1 or C is equals to 1. So that's the idea. So if A is equals to 1, the output should be 0. Okay. If A is equals to 1, the water irrigation should not work. The smart irrigation system should not work. So we can easily put that out. Okay. Now D should be also equals to 1. So if the D is equals to 0 also, we can't have that happen. We can't have water passing through. And the temperature is high or sunlight is bright. Now that's a good question. They're saying B is equals to 1 or C is equals to 1. Here both are 0, so this should not work. And then here we have B is equals to 0, C is equals to 1. So it will be 1. It's the same here and it will be the same here. So we have only 3 min terms here. So that's the truth table given here. So let's go to the second step for writing the Boolean expression. So these are the min terms. Let's write them down. M3, M5, and then finally M7. Now, let's write down the terms. So that will be A bar, B bar, C, D plus A bar, B, C bar, D plus A bar, B, C, D. That's it. This is the standard product of sum of product expression. This is the sum of product expression. Now we have to draw the K map. Since we have 4 inputs, we need 4 rows and then 4 columns. Let's name the directions. This will be AB and this will be CD. Now here we will have A bar, B bar, and then we will have A bar, B, and then we will have A, B, and then finally A, B bar. Similarly, C bar, D bar, C bar, D, and then C, D, and then C, D bar. We need A, B bar, C, D. So 1 here. This is the first term. And then we are plotting the second term, which is M5, A bar, B, and then C bar, D. So A bar, B, C bar, D. And then we have A bar, B, C, D. Okay, we have A bar, B, C, D. So which is this one, A bar, B, C, D. So we have 2 groups totally. Okay, so that's the fourth step, simplification. This is the group 1, which is a column. So we will get A bar, B, and then since we have C bar here and C here, C will cancel out. So we will get D here. Now we can go to the second group. And the second group is, well, we have a row. So CD will come. Now we have A bar, B bar as a unit and A bar, B as a unit. So V will be cancelled. So we will have A bar, CD. So the fourth step will be F is equals to A bar, C, BD plus A bar, CD. Now you can further simplify this. Okay, it will give us A bar, D into B plus C. In both these situations, the NAND gate formatting will be the same. Okay, I mean, we will use different structures to achieve the final answer, but we will require the same number of NAND gates in both ways. Okay, so I'll show you that. Fifth question, so I mean fifth step, we have to rearrange this and draw the circuit. So it will say F is equals to A bar BD whole thing bar into A bar CD whole thing bar, which will require 4 gates. Why? For A bar we need a gate, and then for this one a NAND gate, this one a NAND gate, and finally for the entire thing a NAND gate. So we will need 4 NAND gates. That's the idea. But if I rearrange this one, A bar D into B plus C, I will get A dot D bar dot B bar dot C bar whole thing bar. Here also we will need 4 gates. How did I do this? Well, A bar D B plus C can be given as A bar D and then B bar dot C bar whole thing bar, and then I can say this is equals to A bar D into B bar dot C bar whole thing bar into double bar. So that will give me A double bar dot D bar dot B bar dot C bar whole thing bar. So these double bar will cancel each other out, and we will get finally this final simplified version. In both ways we need 4 NAND gates, and this is actually the simplified version. We are just applying the distributive law in reverse to achieve this term, achieve this expression. So let's go to the designing of the circuit. I'm going to use this one instead of this one because here we need more NOT gates rather than NAND gates. We are changing NOT gates into NAND gates into NOT gates. That's what we are doing. But here it actually sends multiple terms through NAND gates. So we'll use this. This is what we have been learning so far. So we'll do that. So A, B, C, D and their input lines. First of all, we need A bar. So we will send A through, we will send A twice through a single NAND gate, and then B and then D should be sent through a single NAND gate. And then we are sending A bar and then CD through another NAND gate. So let me borrow A bar signal from here and then C here. And then finally we'll have D through another NAND gate. And finally we can send them both through another NAND gate to finally come up with the output, which will be F. That's it. If I did the other way, we will have NAND gates for D bar, B bar, C bar, and then finally all 4 signals send through a single NAND bar. Similarly, but we will use 4 NAND gates. So this is how you have to do this question. Thank you for watching the video on 4 input min-terms K-map simplification. I hope you enjoyed the video and learned something new, and I will meet you in another video. Until then, keep learning and stay curious.